In this video, we're going to talk about the different ways we can represent different compounds. That is, chemical formulas and molecular models. So what is a chemical formula? Well, it just tells us for a given element or a given compound what elements are in there. Or another way to put that, what types of atoms are in there or ions and how many atoms and ions are there. And so you are already used to seeing chemical formulas even if you don't know that. For example, water, H2O, 2 hydrogens, 1 oxygen. Sodium chloride, NaCl, 1 sodium, 1 chloride. Carbon dioxide, CO2, 1 carbon, 2 oxygens. And you can do this for even very complex compounds. So here's a molecule found in your body called ATP, or adenosine triphosphate, and you could give the chemical formula, but it's much easier for the name. Or something like hemoglobin, which is in your blood and it carries oxygen, would be unrecognizable in chemical formulas. So there's different ways to just call compounds, either by name or by chemical formula. In general, there's 3 different types of chemical formulas that chemists use. The first type is called the empirical formula, and that is the relative numbers of atoms of each compound. And the second type is the molecular formula, what is the actual number of each element in a compound. So what does that actually mean? So let's look at 2 different compounds, butane and octane. The actual number of atoms in these compounds are given by the molecular formula. So we have C4H10 for butane and C8H18 for octane. However, to get the empirical formula, you take your molecular formula and you divide it by the greatest common factor. So here for C4H10, the greatest common factor is 2. So you divide each by 2 to get C2H5. For octane, again, the number is 2, the greatest common factor between 8 and 18, and you get C4H9. The third type of structural formula, third type of chemical formula are structural formulas. And that is, we use lines to represent covalent bonds, and we show how atoms in a molecule are connected to each other by these lines. So not only it shows the atoms explicitly, but it shows how these atoms look in 3 dimensions. And we can show some details like how many electrons are shared in a covalent bond. Now, when we talked about covalent bonds in the previous video, I showed that there was 2 electrons between a carbon and a hydrogen. We call that a single bond. Well, elements can actually share 4 electrons between each other, and that's called a double bond. Or they can share 6 electrons from each other. That's called a triple bond. And generally, you cannot share more than 6 electrons. You can never have more than a triple bond in a covalent bond. And the last slide we're going to look at is just looking at molecular models. So throughout the book and these videos, you have seen molecules be presented by these spheres. We use these spheres to represent atoms, and these colors actually mean something when you're looking at atom models. Usually if something is black, it's a carbon. If it's white, a hydrogen. If it's red, it's oxygen. And if it's blue, it's a nitrogen. You really need to be knowing just these 4. The other ones are more rare and they don't pop up as much. But let's just look at how we can use these different chemical formulas. For benzene. So benzene has a molecular formula of C6H6. The greatest common factor is 6, so the empirical formula is CH. If we use a structural formula, this is what benzene looks like. And we can use what's called a ball and stick model or a space filling model just as another way to visualize the structural formula. Okay, that's it for this video. See you in the next.